So, this is chapter 3 in our unit 6 notes for forces and interactions. This is going to focus on forces and action. So, we're going to talk about contact forces and some non-contact forces. So, a skydiver jumps out of a plane. So, we want to think about what happens to their speed as they fall and why don't they keep speeding up forever? These two questions are going to be two big questions that we're going to be thinking about. And we really want to be thinking about how do forces affect real life? So, forces in action. Forces are always acting on objects around us. So, forces can speed up objects, example, like a car accelerating. Forces can slow down objects, so a rolling ball stopping. Forces can change direction, so a soccer ball being kicked. And forces can keep constant speed. So, example could be a skydiver when gravity and air resistance are equal. So we have contact versus non-contact forces. Contact forces require touching. So we're talking about drag force, frictional force, normal force, spring force, and applied force. Non-contact forces act at a distance. So there's no contact. This is magnetic force, electric force, and gravitational force. We're going to first start by talking about contact forces today in action, and then we'll end the lesson talking about non-contact forces in action. So friction is a contact force. So friction is a force that opposes motion. Friction happens anytime any surfaces interact. So friction always goes in the opposite direction of motion. In this example, you have a rough surface, motion's going this way, friction's the opposite direction. What affects friction? Friction depends on texture. So if something's more rough, you're going to have more friction. And friction also depends on the mass. So more mass is more friction. So, types of friction. There are four different types of friction. So, static friction is when the object is not moving. So, the force and friction are equal, so you'll get no movement. Sliding is when the surfaces are sliding. So, if you have a sled, the force against the friction, and you'll get a sliding motion. And you can rolling friction, an object is rolling. So for rolling friction, you have the force against the friction and then a rolling motion. And then fluid friction, which is drag, it's moving through air or liquid. So if you have a swimmer moving through water, or if you have someone skydiving moving through air. So comparing friction types. So the strongest friction is static friction, right? Because you have no movement. Sliding is in the middle. And the weakest friction is rolling, which makes sense because if you think about it, if something's on wheels or something's round, it generally is easier to move. Fluid friction, drag, depends on speed and the surface area of that involved. So when we're thinking about our parachutes that we designed, we want to think about like the surface area that we created for our parachutes. Drag and action. So drag is equal to friction in fluids, so air or water. Faster speed is more drag. And then the bigger surface area also gives you more drag. So gravity in action. Now we're going to talk about some non-contact forces. So gravity is a force that pulls objects towards Earth. This causes objects to fall and accelerate downward. Acceleration due to gravity. So when gravity pulls objects towards the ground, it always causes them to accelerate at a rate of 9.8 meters per second squared. Regardless of the differences in mass, all objects accelerate at the same rate due to gravity unless air resistant affects one more than another. So if you have this ball dropping, you see that at each interval of second, it's doubling by 9.8 meters per second. So it's accelerating at the rate of 9.8 meters per second. So this ball will consistently fall that way unless air resistant affects one more than another. So when we're talking about free fall is when only gravity is acting. So there's no air resistance, and this happens only in a vacuum. So for free fall, that all objects fall at the same rate. So here in a vacuum with no air, you can see this piece of paper and rock will fall at the same rate. However, on Earth, air resistance changes motion. So drag affects objects differently. So the piece of paper with more surface area is getting affected by drag, therefore it's having a slower fall time than the rock. So what happens when objects fall? So gravity pulls the object down, the object speeds up. When there's a change in speed, it accelerates. The air resistance increases, and then forces will eventually begin to balance as the object is falling. Terminal velocity. So terminal velocity is the maximum constant speed a falling object reaches when the upward force of air resistance, drag, exactly balances the downward force of gravity. So in picture one, you have the skydiver falling from the sky. In picture two, air offers resistance, resulting in an upward drag force. And then in picture three, at terminal velocity, you'll see these two arrows, so drag force and the force of due to gravity equal out. So at this point, the object stops speeding up and falls at a steady rate because the net force is zero. So when your forces are balanced, this skydiver is going to move at a constant speed because the forces are balanced. So, what affects falling speed? So, mass affects how drag impacts the object. Um, the surface area will also affect the falling speed, and then the shape will also affect the falling speed. So, as you see, the skydiver, when their body is taking up more space, they're falling slower. As they become more streamlined, they start to speed up. So, now we are going to continue talking about non-contact forces in action. So let's talk about electrical force. Electrical force is a force between objects with an electric charge. Electric forces can attract, oh, Milos. Electrical forces can attract opposite charges. Electric forces can repel same charges. For example, in class, when we did the balloon and hair demo, the balloon on the hair shows the electric force acting without touching, right? The hair starts to move even before the balloon touches the hair. The electrons move to the balloon. The balloon becomes negatively charged and the hair becomes positively charged. The opposite charges create this attraction between the hair and the balloon. So, electric fields. Electric field is a region around a charged object where an electric force can act. So the closer you are, the stronger the force. The farther away, the weaker the force. So in this GIF right here, the paper ghost moves before touching the balloon. This is evidence of an electric field, right? There's no touching, but you see movement. For electric field lines, the more lines you have in an electric field diagram means the stronger the field. And you can see you have your positive and negative charge for the electric fields. Magnetic force is a force between magnetic objects. Magnetic forces can attract, So if you have opposite poles, a north and a south pole will attract, or they will repel. So if you have the same poles, a north and a north, or a south and a south, they will repel. So in this GIF, you have a south and a north, so they're going to attract, they're going to combine. For these two magnets that are moving, you have repelling forces. So these are going to be the same poles next to each other, which is why this one magnet is moving magically. Only certain materials are magnetic. The most common ones are iron, nickel, cobalt, neodymium, gadolinium, and steel. So, magnetic fields. Magnetic field is a region around a magnet where magnetic force acts. It's strongest near the poles and it weakens with distance. So, when the paperclip moves towards the magnet, it moves before touching. Therefore, this field is acting. It's proof, right, that this field exists. Very non-contact forces. So we have three big non-contact forces: gravity, electric, and magnetic. So the force type for gravity, its cause is due to mass. So if the mass increases, the force of gravity increases. Does it attract? Yes. Does it repel? No. So you won't see anything getting pushed away without touching. But you will see things getting pulled down due to gravity. Electric. So the cause is its charge. If you have positive or negative charges, does it attract? Yes. And can it repel? Yes. And then magnetic, the cause is the poles. So you'll have a north and a south pole. Does it attract? Yes. If you have the north and south, they will combine. Does it repel? Yes. If you have the same poles next to each other, they will repel each other. Fields. Field is an area where a force can act. So you have a gravitational field, an electrical field, and a magnetic field. All of these forces act through these invisible fields.